This video describes assignment number 1 for Computer Science 115. Assignment number 1 has two main parts. One part is to take input from a file and store it in a two-dimensional array. And then, from time to time, we need to output the information from the 2D array onto the screen. So that's one of the main parts of assignment number 1, taking input from a file, putting it into a 2D array, and from time to time displaying it on the screen. The second major part is, given a monster in a 2D array in some location, we want to plan to reach a destination as in terms of what moves the monster makes. Perhaps he goes to the east, or to the south, or to the east, or to the south, or to the east. So this planning of the moves assumes there's no difference in going the various directions in terms of cost, and so we just figure out a path to get from where we start to where we end. Stop. So in the first part of doing assignment 1, we want to think of taking input from a file and placing it into a 2D array. Our mission is to think about taking input from a file, or you can think of it as representing characters, and storing it into a 2D array of numbers. I'll just use a small array here to demonstrate the techniques. We'll imagine that we have a file that has 4 lines with 5 characters on each, 5 chars on each line. And our job is to read in the characters one by one, but instead of storing the characters directly, we will store the corresponding integer. What kind of things might we have? Well, we have an S, which represents the starting location of the monster. We have a P, which represents where the player is, or the target of the monster. Start of monster. Player, and so forth. But we don't want to store those characters, we want to store the corresponding numbers. So say 4 for a player, 6 for the start of the monster, and so forth. So let's just see some of the characters we might have in the file. 5 by 4. We might have something like a dot, just a period. A period is equivalent to empty. So period is empty, and we're going to use a 0 in the array to store it. So when we read in the first 3 characters, we look at them one by one. First one happens to be a dot, so we'll be storing a 0. The next one's a dot, 0, 0, and so forth. And let's suppose that we have the S occurring next. S corresponds to number 6, so we'll store a 6. And then perhaps we have a little hat, a circumflex. And a circumflex will be a 1. And that indicates a somewhat rocky terrain. So where we see the circumflex, we want to store a 1 in our array. And then we just move on and see what else we have. Perhaps we have another circumflex. Then we have another one. And then suppose we have a colon. Two dots, one above each other, a colon. We're going to make that into a 2. And that represents rough terrain. So we store the 2 next. And we proceed in this fashion. On page 3 of the assignment, there's a table giving all the possible values. We have a dot, as indicated, is a 0. A circumflex or hat is a 1. Colon is a 2. A number sign or sharp sign is a 3. P is a 4, as we mentioned. A star is a 5. An S is a 6. An A and D we won't actually see in this assignment, but just put in the code to handle them anyhow. A is a 7 and a D is an 8. So our job is to read in a file. So many rows, so many columns in each row, many lines of text. And for each character, fill in the corresponding number in the 2D array. And we'll just keep filling in the input here a bit. Maybe we have a number sign, another colon, a number sign, some more dots, colon, number sign, and then we'll put a P down in this corner for where we're going, and maybe some hats along the bottom. And that would correspond with our number sign there to a 3. Colon was a 2. Number sign is a 3. And dots are zeros. Colon is 2. Number sign is 3. Hats are 1s. And the P is a 4. So that completes filling in our 2D array from our input file. In the next part, we want to take output from the 2D array. So here we start out with that same array as before, and then we just convert it. We look at how we could print it out. So just that same array I had, maybe some other part of the program. Remember, it had 5 columns, it had 4 rows, and the values in it were 0, 0, 0, 6, 1, 1, 2, 3, 2, 3, 0, 0, 0, 2, 3, and then 1, 1, 1, 1, 4. And we would like to print that out. And what we're going to do is we're going to use some different output symbols. So on page 5, we can see some further symbols. We can see that where we have a 0 in the output, we should put a space. Where we have a 1, we should put a hat. Where we have a 2, we should put a colon. Where we have a 3, we should put a number sign. I'll just remove that part. A little error. Where we have a 4, we'll put a space. Where we have a 5, we'll put a star. 6, 7, 8, we'll just put spaces. So that's how we'll be doing our output. So in our case, we would look it up and say this was output on the screen. Well, part of the output that we want is we just want to put a space. Can't see a space, so show an underscore, but really that's a space. Then for 6, it says we need another space. For 1, we need a hat. So put the hat. Then we've got another hat, a colon, a number sign, and a hat, and a number sign. Sorry, not a hat, but a colon. So we're just going along, looking at our numbers, going for the first row, going across all the columns, looking to see what's there. It's a 0, so we print a space, a space, a space. For 6, we're supposed to print a space. For 1, we print a hat. Then we move on to the next row of the array. We print a hat, colon, a number sign for the 3, colon for the 2, number sign for the 3, then some spaces, and a 2 should be another colon, 3 another number sign, and 1s are all hats. And finally we get to a 4, and a 4 is a space. So that's the simple way of thinking about the output. We're going to make it just a little more complicated than that. We want to print a nice border around the output as we're printing it. So before we get started with the first row, we'd like to print a plus sign, 5 minus signs, and then a plus sign. Then before printing the content of each row, we'd like to put a pipe symbol. This is a pipe on the keyboard. Sometimes it just looks like a straight bar. Other times you can see a tiny little space in it. And it might be called a pipe or a vertical bar. So on your keyboard, forget where it is. I think it's sort of over on the right hand side near the little finger. So we'll put those as well. So we end up with a nice looking display with the world shown in this kind of border. And we'll conclude with another line with a plus sign and 5 minuses and a plus sign. Sorry, ignore that. There we are. So that's what our output looks like. And so this is a separate job that we'll be doing. We'll be using some kind of function to print the values. We'll look at the integers. For each integer, we'll print a character. If it's a 0, we'll print a space. If it's a 6, we'll print a space. If it's a 1, we'll print a hat, and so forth. So that's kind of the end of the first part of what goes on in this assignment. Another part of this assignment was moving the monster. So how we'll do it is a little bit in slow motion. Our person who's using the program will hit the enter key, and then the monster will move one spot, and the person will hit the enter key again, and the monster will move, and keeping it working its way across the board. It starts where we had that S in the input. We ended up recording that as a 6, and it goes to where there was a P in the input, and that we recorded as a 4. So just to remind you, in our array, we would have started with the monster at position 6, where there's a 6, and end with the monster in position 4. In this case, if we look at it, well, we can see that the monster mostly needs to go down in the array, and I'm going to refer to that as south. Go down towards the south. We'll call the top of the array the north end of it. And of course the sides are east and west. So we've got north at the top, south, and when we think of the array as having positions, its rows are numbered 0, 1, 2, 3, and columns in this case are 0, 1, 2, 3, 4. So we've got some columns and some rows. So we want to move from row 0, column 3, through a series of steps, and then finally end up there. And the way we're going to do it is we're going to try and kind of gradually approach. So originally we're further away in the vertical direction, so we'll start moving down that way, and eventually we'll complete the motion to the right. And we won't just do all of the vertical and then the right. When it's, if there were a different location we had to get to that was further off this way, we would move in more of a, I don't know what we call it, kitty corner fashion. But let's just look at that first example. What we need to do is move down, move down, move down, and then move to the right. So monster movement, we're going to write a helper function. And the helper function does a simple task. If we have any kind of location with the monster start, say, that was our 6, I guess, and then that, we're just going to write a function that, given a row 1 and a column 1, so that location, row 1, column 1, has some parameters, and a row 2, column 2, say some other location in the array. We just want to determine the distance from one to the other. So in order to determine that, we kind of know, we could count off like this, how many moves straight to the right, how many down. But suppose we want to know the Euclidean distance, the straight line distance, something like that. Well then, it looks like a triangle, so Pythagoras seems relevant here. We know some notion of c squared equal a squared plus b squared, but we don't have any c's or a's or b's. We're going to use one of these as a, one of these is b, one of those is c. So we'd like to know that distance, the distance c, look at that. Well, this was c squared, but if we took the square root of a squared plus b squared, then we could figure out what c is. And again, how much is a? Well, a looks like we're going along sort of to determine how far to the right it is. So we would do that with something like column 2 minus column 1. And that could be a. And b maybe is row 2 minus row 1. And then there's a matter of squaring things. And in computer science, we can use a POW function. We might say power of a to raise it to the power of 2. That would work. But a really simple way is just a times a. If you needed to know how big a squared is, it's just always a times a, and that's really easy to write. It's even easier than calling a function. So you might do it that way. We also talked about moving the monster. And we're going to do that sort of by checking out the choices. Say the monster is in a certain location. Maybe I'll use a little bigger graph array here. A little bigger. So we want to go to some other location, and we're not sure which way to go. So what we do is we say, well, there's 4 possible locations near the monster, and all of those are possible moves. If the monster isn't already at the destination, then we could try 1 position to the right, 1 position above, 1 position to the down, or 1 position to the right. And we could measure the distance for each of those here. We have a function that will compute the distance. We just calculated that. So we could measure all of those distances, measure 4 distances for the possible moves. So these are possible moves. And then pick the smallest one. So that's the main idea here. Now we just have to think a little bit about how we might do that, what those 4 positions are. So let's just think about those 4 positions. Again, in an array, maybe we're considering with our monster is located at, what would be a better name? Maybe monster row, monster column. That's going to be way too long to write. So just for now, I'm going to use I and J, just to give you an idea of the positions. So here is where the monster is. The monster is at IJ. And this position, if you look at it, where I is coming down from 0 all the way along, if this was I where the monster is, this one up here is I minus 1 and J. Another one nearby, our monster, say here, well, it looks like it's in row I, but in J minus 1. Another one is in row I plus 1, column J. And another one is in row I, but in column J plus 1. So that's the main idea. Instead of being where the monster is, in our, say our array is A position IJ is where the monster is. The nearby positions have very similar looking positions. We just change I or J by 1. We don't change them both. That would give us our corners, and we're not going to consider those. We're just going to consider moves east, north, west, and south. And I guess a complication that we'd have to worry about is we don't want to go outside of the array, because we know we're not allowed to refer to a position out of the array. So if we were in row 0, so I was equal to 0, J is something, maybe 3. Well, in that case, we only have 3 positions we're interested in. So if I is equal to 0, we're not interested in going up into I equal minus 1. So we might have to be careful about that. Perhaps we'll say if I is greater than 0, then we would be interested in that position I minus 1, J. So we would look at that array position. And it's the same for the other sides. So that gives you an idea of some of the main parts of doing assignment number 1 for Computer Science 115 in the 2019-10 term.